Okay, the next section we're going to talk about is 8.2, special right triangles. Of all the sections we cover, you're probably going to see this one the most from here on out in math. When you get into Algebra 2, pre-calculus, calculus, this is a big emphasis, so it's very important that you understand special right triangles. The special right triangles are 45, 45, 90 and 30, 60, 90. And I think it's very important that you understand where each comes from. If you understand where they come from, I think you'll better understand the pattern. Okay, the first special right triangle that we have is a 45, 45, 90. And I think it's really important that you understand a 45, 45, 90 comes from a square. Okay, now we know a few things about squares, so here we go. Here's a picture. Okay. Some of the basics for a square, you should know that each side is the same. And in this case, we're going to call each side x. So a 45, 45, 90 comes from when you take a square and you cut it with the diagonal. You know, one of the things I know about a square is that it has a right angle here, and that if that's x and that's x, this has to be an isosceles right triangle. Now, if I remember about isosceles right triangles, if these two sides are congruent, then the base angles here are congruent. That's where our 45, 45, 90 comes from. So if these are going to be congruent and they have to add up to 180, those would both be 45. Just going to focus now on just this bottom triangle. With a 45, 45, 90, there's a pattern associated with it that you really need to know. First of all, you should always know that these two sides, the legs, will always be the same. It's an isosceles right triangle. So these are the same. Let's say we're looking for this diagonal here. We'll call it D. Okay. I would like to find D so that I know the relationship between these legs and that hypotenuse. So I'm going to apply the Pythagorean theorem. X squared plus x squared is 2x squared. Since we're looking for D, I'm going to take the square root of both sides. If I take the square root of both sides, the square root of D squared is D, and I'm left with this right here. Now keep in mind, if we're going to simplify this radical, part of this is a perfect square, part of it is not. Now, normally we don't see x squared here, but this is a perfect square. The 2 is not a perfect square, so it stays behind. So now if I take this and plug it back into my triangle, you can see that this diagonal will always be bigger than these two legs. In fact, it will be exactly radical 2 times bigger than these two. That's the pattern you guys need to know. These are the same. This is always square root of 2 times bigger. Square root of 2 is around 1.41. So I'm going to use this when I'm finding missing sides of triangles and I know that it's a 45, 45, 90, or if I know it's a diagonal of a square. It's a pattern that's really a shortcut. I guess I could always use the Pythagorean theorem if I have enough information, but if you know this, it's going to make your life a lot easier. Okay, if you didn't understand how we came up with the sides with a 45, 45, 90 degree triangle, that's okay. The thing you just have to remember here is the pattern. How do you find a missing leg? How do you find a hypotenuse if you're given such a triangle? So one thing to remember, if you have a 45, 45, 90, is that it's half a square. If I keep that in mind, then I know that these two sides will always be the same. So if you have this side, it's always going to be the same as this. This is an isosceles right triangle. To find the hypotenuse, You take the leg and you multiply it by radical 2. So something to think about here. If you're uncomfortable with the square root of 2, just remember that it's a number. The square root of 2 is approximately 1.41. So some things to remember in this pattern. If they give you the 2 legs, to find the hypotenuse, you just need to multiply by radical 2. In a 45, 45, 90, if you reverse the process, if they give you the hypotenuse, to find the leg, we're going to make it smaller. So from the hypotenuse to the leg, you divide by radical 2 or divide by 1.41.
Well, it's another great day to be a Titan.